say z is, let me get rid of the quotes here. So your choices, let me put it this way. Your choices for y are this, this, and this. All right, so this one, the first one is he typically calls, no, it's just notation. I'm so sorry. So u equals to y plus z is the first one, okay? And the second choice, if instead of using the cube root, we use like omega times the cube root for the second one, then we have u equals to omega y. And so the thing is, this is z over omega. This is the thing I'm failing to say, z over omega. This is z over our original z. I should like use y naught and z naught here. How about that? That'll fix everything. Right. So q, this is z, this is z naught. So z naught over omega. So this is, so the thing is 1 over omega is omega squared. So this is omega squared z naught. And I'm going to, well, I hope I won't regret that. The other choice is u is omega squared y naught plus omega z naught. Because 1 over omega squared is z naught. So these are the, well, these are the three solutions. These are the three solutions to the cubic that you're looking for, where he says where y cubed is 1/2 times the square root of minus r plus, that's enough, brief, come on. Where y cubed is 1/2 of minus r plus the square root of r, big R, where big R is r squared plus 4q cubed divided by 27. So there, I guess the question is what's the z naught, right? How do you find the z? That's given over here. Right, so you find, again, you find the y, then you find the z, and then you can put them together using the third roots of unity in a square, like that. Good. So, let me give you 2 examples. I think I can erase this stuff here, actually.
Yeah, I pick a poison.
So, example, this is example 16 on page 46, Robin. By the way, I have a, you can borrow a copy of this if you want. So he has f of x equals to x cubed minus 15x minus 126. He's started us with a depressed cubic, which is kind. So it's already reduced, all right? And here, so we have q equal to, oh, we got q equals to minus 15, and r equals to minus 126, right? So the r, which is, you know, r squared plus 4q cubed over 27, well, that is obviously 15,376, right? So the square root of r is 124. All right. And so what we're solving then, we got to solve y cubed 1/2 of minus little r, so that's 15, right? plus the square root of r, yeah. Oh, I did that wrong, didn't I? What was little r?
Little r is 126.
Minus 126, right?
Yeah.
So the formula is minus, so I'm doing this one right here, right? Minus r, which is minus a minus 126, right? Plus the square root of r, which here is 124. So what we've got is 250, well, we've got what? 250 over 2. So it looks like y cubed is 125. Man, this example is nice. So y is 5. Because the cube of 5 is 125. So what's z equal to? What's the rule? Z is...
We have
Z is equal to minus q
Q,
over...
y. So we have minus q over 3y.
Right, which is...
So 15, and then q is minus 15, so it's 1 or minus 1.
Yeah, it looks like q is... Well, the minus and minus cancels, so we get 1, right? So then our solution, u, is y plus z,
Yeah.
which is 6. And then the other two solutions, we can get with what? We can also do like, let's call it u1. The other solution, u2, we can get from, the third root of unity omega times y times 5, right? Plus the third root of unity squared times z naught, which was 1. And the third solution here would be omega squared times 5 plus, omega times 1. And those work out to minus 3 plus 2I root 3 or minus 3 minus 2I root 3. Of course, they had to come in a conjugate pair
Yeah.
because this is a real polynomial. One more example that we're done. My apologies to your coach.
You got 5 minutes. And I'll be alive.
Okay,
I'll be fine.
don't hurt yourself. Let's see here, so example 17. He gives f of x cubed minus 7x plus 6, all right? So this one, you get y cubed equal to 1/2 square root of minus 6 plus the square root of minus 400 over 27. So one choice of u ends up being the third root of 1/2 of minus 6 plus the square root of minus 400 over 27 plus the cube root of 1/2 of minus 6 minus the square root of 400 minus 400 over 27. All right, if we went through you figure out what the q is, and I mean, you can see what the q is -7, right?
Yeah.
And the little r is 6 here. And so this is the, y plus z thing. And, but then here's the thing that's so messed up about this example. This, you can check, is x minus 1 times x minus 2 times x plus 3. So f of 1, f of 2, f of minus 3 is equal to 0.
I just need to know how this I pops out.
So, question is that 1? Is that 2? Or is that minus 3? See, this is the thing that's so messed up about the cubic formula in some sense, from the 15th century, 16th century perspective, is this is a polynomial with real roots. But the cubic formula, which we have derived today, requires I'll call it back in a minute. It requires
an I.
It requires a not.
Yeah.
This is what the point of that video was.
Yeah. Because they thought, but they took it as like, they thought negative numbers weren't real either. They thought there was the necessary algorithm.
Right. So negative numbers were slightly abhorrent, but imaginary numbers, well, that's beyond the pale, So there it is, though. And I actually don't know which one this is. He doesn't say in the book which one it is, whether that's 1, 2, or minus 3. And it would take me, I don't know, like and this is not uncommon. Like some of the presentations of the roots that the cubic formula gives you, it need not be nice. Like it can disguise.
Oh, I've seen the whole thing before.
Yeah.
So my teacher made us do it. It was
Cool.
solid.
But anyway, that's it. That is it. That is the end of our Galois theory. So I do have a question about differential Galois theory in your homework. So I could talk to you more about that some other day. I do have some videos posted of it. I've never really done that justice because my brother spent like a third of his semester in class developing that stuff, so I have a handout for it. I'll talk to you more about that some other day.